Thank you very much, Peter, and thank you to all the participants of this session. My name is Alex Hodik. I'm the General Manager of Optomec Asia Pacific. Today's session will be about our proprietary technology, Aerosol Jet, solution for printed electronics. We will go through the different industries and the different capabilities that we have with multiple applications within the electronics field. And we will share a bit more about the actual solution and the different products within the portfolio. Okay, so let's start. Sorry. Okay, so a few words about Optomec. So Optomec is an American company, very mature company, been around for more than 3 decades. The company has two main product lines, which we specialize in. One is aerosol jet technology for printed electronics solution. And the second product line is not related at all to electronics, which is metal additive manufacturing technology. Metal 3D printing, if we can say that. So we will, as I said, today we will focus on aerosol jet, but in case you do want to hear more about the metal AM side, we are more than happy to take it offline, and you can approach us or DETEKT team with more questions, and we'll be happy to address those. So the company has been around for a while, as I mentioned before. We have very, very decent install base globally from both technologies throughout the years. We are very, very active in generating new IPs and adding new capabilities to our solutions. The company has a very strong global reach. So throughout the years, we've established a lot of partnerships in the different markets. And in some markets, we operate directly. In other, we operate through distribution or a mix of both. We have, in terms of direct presence of Optomec globally, we have 3 offices in the US. Each office specializes in a different capability of the company. In terms of commercial and support reach, we have an office for EMEA and so for European market and the Middle East market, Africa and Middle East market from Switzerland, supported by Switzerland office. And our office here in Singapore with myself and the team included with applications and customer support capabilities to support the Asia Pacific region. Okay. So as mentioned previously, we have 2 main product lines. One is metal AM. We will not go into that, but really it's a wide variety of systems that can address different needs and requirements within different industries that involve metal fabrication of components or repair of components. Today we will focus on aerosol jet. So aerosol jet is a method, a unique method to dispense ink, different types of inks, and we will go over the different capabilities, of course, but dispensing ink on top of a planar and non-planar surfaces or substrates. Okay, the company is, as mentioned, been around for a while. We've, throughout the years, we've established a very strong install base with really leading brands, leading industry brands, and you can see some of the logos on the sides of this slide. The technology itself, so the concept is somewhat simple. We take the ink and we atomize that ink. There are 2 ways to atomize ink. One is ultrasonic and the other one is pneumatic. Okay, so ultrasonic ink, ultrasonic atomization is mostly directed towards more finer ink and for finer applications, while pneumatic is more on higher throughput and let's call it but larger particle size types of inks. Once the ink is atomized, we basically create a mist, and that mist is basically feeded into the jetting system. Okay, so here we can see on this side a nice illustration that shows the mist coming into the nozzle, and then using sheath gas, we are able to create a higher velocity for the actual jetting. Okay, and we actually have and this also gives us the capability to focus that stream and to ensure that we are very accurate in our jetting process. Another good benefit of the gas that comes from the sides is the fact that the actual stream or the mist has no contact with the sides of the nozzle, which of course ensures a smooth operation without clogging, etc. Okay, and sorry, and one more important point here, by the way, is of course the standoff distance. So we are, because of the process and the way it operates, we are able to maintain the same width of jetting or the same width of line of feature on whether we are jetting from 1 millimeter distance or from 5 millimeter distance. So a range of 1 to 5 millimeter distance will deliver the same consistent result of the line width or the feature size. Okay, and you can see how this positions us very well in different applications, which we will address, like interconnects, etc. Because we are now able to treat those kind of processes as a 2D type of application. We like to call it 2.5D, okay? But basically, it's not a three-dimensional application, while we do have certain curvatures and certain steps. So this is a very, very nice capability that really gives us a wide range of, opens a wide range of possibilities. In terms of the process, so it starts with design. We design the actual pattern, whether it's a 2D drawing for the pattern or the tracing that we would like to print, or a three-dimensional CAD model for 3D applications, meaning to print something on a three-dimensional substrate. So we can see here a nice example of a globe, okay, but it's a nice example just to show the capability. But in real life application, we're talking about antennas, we're talking about printing sensors on unique structures, and more interesting applications from different areas, even like medical. Okay, so we print the part, and after printing, we of course need to post-process, right? So post-processing in this world will include, of course, UV curing for polymers, adhesives, and other materials. Sorry, it jumped. Oh, yep. And UV laser sintering for metal inks. Okay, now there is always an option to do, of course, oven sintering and curing as well, which is an external process. But we will address the UV and laser sintering more in depth, because this is something that can actually be integrated within the system, within our technology, and is part of the process, which makes the whole operation very attractive, because from start to end, you start with the design and you take out a completed part without the need of additional post-processing or external post-processing. So aerosol jet, the technique itself is very useful for multiple areas. Of course, we mainly operate in the electronics world with fabrication of active components, passive components, sensors, and more. But it can also be, of course, integrated in different other processes around structures. So I will show you later on some nice examples of micron level structures, 3D structures that can be fabricated or printed using the aerosol jet technology. And of course, some nice examples from the medical the biomedical device type of applications as well. Here on the side, we can see some nice videos showing the different capabilities. So here you saw the interconnects for a stack die. Now we are looking at a video showing basically an antenna printing on an injection molded substrate. And below we can see a nice circuitry printed for different applications. In terms of materials, so aerosol jet can really operate with a very wide range of materials, from metal inks to resistor inks, dielectric adhesives, non-metallic conductors, semiconductors, and more. Very important to say, and you can probably see that in this list, you see suppliers of inks, right? Companies that you most likely know and names you most likely know. In the brackets, you will see the actual material from those companies that we are printing with. And this is a very important message, because the message is that we, Optomec, do not manufacture materials. Okay, we do not manufacture materials. We are providing a solution. We are providing a technology, a process of taking different materials and dispensing those, but we do not get involved in manufacturing of the materials, for the simple reason is that each manufacturer, and most of you will probably agree with me, each and every one of you has your own, you have your own unique needs for your unique application. So it's very hard to say that one ink will be able to answer all requirements. So, and eventually in some cases you also have your own formulation that is created in-house. So that is why we decided to stay material neutral, okay, and to really to provide a platform that is flexible and versatile enough to be able to work with multiple types of inks and substrates. In terms of application landscape, so this is a nice slide just to show if we try to group it in a way. There is one additional group that I'll mention in a second. But so advanced 3D packaging and assembly, we have a lot of engagement with multiple leading brands in the area of interconnects, in the area of packaging optimization. Okay, and of course other different applications within the world of semicon and PCB, such as EMI shielding, RDL, etc. Okay, so a lot of different capabilities, as I mentioned, due to the flexibility of our technology. Printed sensors, this is a big one and really something that can be implemented in different industries. So from more industrial applications to medical applications as well. So we can see here a few examples, and within the slides we'll go a bit deeper into that, and I'll show you a few more. Printed antenna, so communication. The area of communication is a very important, very big area, especially with mobile devices, different mobile devices around. This is becoming a big need, and Optomec with its aerosol jet technology can actually provide very interesting solutions that can cater for existing types of applications, and also for the newer type of applications when we're talking about below 6G or 5G applications that require a very unique set of skills. It requires very fine type of circuitry being applied and printed on antennas. And with Optomec, we can go extremely fine. So we are talking about lines that can go down to as low as 10 microns. Okay, so very, very fine feature size can be applied, and that gives us the freedom to operate in these kind of unique and new applications. Another one that is not mentioned here, but I will go through it in the slides, is display. So the display world is a very vibrant world, and we see ourselves as strongly positioned there for especially for an interconnect application, which I will show you again in the coming slides. So standoff height, this is something that was mentioned previously, but this is really one of the key things within the aerosol jet technology that allows us or gives us that kind of freedom and flexibility to really get very creative in terms of applications. So as mentioned previously, 1 millimeter to 5 millimeters, some cases even more than 5 millimeter, we actually maintain the same width of the printed feature, okay, which gives us the options of doing these kind of applications, printing interconnects, okay, or printing tracks on top of steps, basically, okay. Although this seems to be a 3D type of application, we actually, in terms of the system, while we are in this range of 1 to 5 millimeter, the system will actually treat it as a two-dimensional application, okay? In reality, it's basically 2.5D, let's call it, that gives us the option to create, for example, interconnects on this stack die. So we have 8 levels here that we are able to connect in a very quick motion. And you can see in this video how this works. The system just goes and prints that tracing all over the steps area, okay? Yeah, so here we can see also some other examples, which we'll see in other slides going forward. Here are a few more examples of for advanced packaging, so chip to board level type of applications, so printed into interconnects and tracing. Okay, so the system, because as I said, we can operate with multiple types of materials, the system will actually be able to print the electric material to create the fillets and to create the insulation, and it will also be able to do the conductive tracing. Okay, so the system can really provide a multi level solution. Here are a few more examples. Routing on die, routing on PCB. So yes, different creative methods can be applied with this technology. Here we see the same video and the images that I've shown before. So a rounded profile versus a flat profile. So we can actually, using this technology, we can also control really the way we produce the interconnect itself and the shape of the interconnect. Okay, just by controlling the parameters of the actual printing. So, you know, when we're talking about interconnects, of course, automatically we start thinking about wire bond, which is still a widely used application, probably most highly used application for interconnects. It's a very mature technology, been around for a very long time. In terms of process economics, it makes sense, and in terms of throughput, it makes sense. However, there are certain challenges for wire bonding. One of those challenges is, of course, the distance, okay? So package height, so the distance between the dies, between the dies. And of course, the fact that you will have certain loop height, which is also another factor that will limit your package, or I would say limit the optimization of the packaging itself. Another possible drawback is the fact that that loop or that wire bond loop is prone to breakage. Okay, so basically using the aerosol jet technique, you can see it's a very flat technique that does not require any loopholes. Okay, any loops. Sorry. Okay, so that really gives us the option to fully optimize packaging and to go very narrow or very thin, actually, more accurately to say. So commonly within the semicon, PCB, so in general packaging industry, automation is required. So we have solutions that were created with that in mind. So here we can see one example, our AJHT system. Okay, so this system is basically, it's a 2D or 2.5D type of platform that is a perfect fit for say packaging, PCB assembly, etc. applications. It also has a load unload area, so it is automation ready. Okay, which means that it can be integrated into a production line very easily. In other cases, customers will require, or let's say one head solution is not enough. Okay, and customers might require a multi-head solution, or they might require additional solutions like the actual EFAM to be integrated, etc. So in that case, we work very closely with our partner DETEKT, who is doing this session together with us, into creating solutions for those customers that have those unique needs. Okay, so integration or building machinery is not a showstopper for us. Can definitely be done together with our partner DETEKT. Okay, so now let's move to a communication area. So we spoke a bit about it. Of course, you know, the mobile world and smart devices world that require communication devices or built-in communication platforms like antennas and other type of devices like Wi-Fi and Bluetooth antennas, etc. We have a very good solution for that, as I mentioned before, because we do have platforms that can also operate in a 3D area. So it is very simple for us, and I will show some examples later on, to actually process a three-dimensional substrate injection molded part that we can easily print on. Sorry, we're getting here some messages I see on the chat, so I guess we'll address the questions later on. Okay, do we have some people waiting for admission? I'm not sure I understand the last message.
Yeah, Alex, you just go to participate, then you can see if there's anybody waiting for.
Let me see. Okay, I'll open because.
Yeah, Alice, please invite some guests on the waiting list. Thank you.
I don't see anyone on the waiting list, to be honest.
Oh, yeah. Okay. Yeah, just go ahead.
There was one person before, which I admitted. Yeah. Okay. So I think we're okay now. Okay. Okay. Now there is someone new. Okay. Good. Okay. So let's continue. Sorry for that. So yeah, so for the communication area, because of the flexibility of the system and the ability to operate on three-dimensional substrates, we can very easily accommodate multiple applications using different conductive inks. Yeah, let's maybe continue with the slides. Okay, so here we can see a nice production application of printed antennas, 3D antennas. So this is a customer, it's a major brand from China. This facility specifically is in China. The company itself is not necessarily Chinese, but for their production facility in China, we needed to create a solution that will be able to deliver up to 20 million units a year. So a 24/7 operation is required. So our standalone system with one head was really not enough in that kind of case. And what we decided to do is to actually customize and create a system with 4 heads, so quad head system to do this printing. So we can see here a nice video showing the process itself. But this really comes to reinforce the message that we are more than happy to customize and accommodate different production needs. Okay. So why to print antennas? So again, there are multiple reasons. Of course, you know, flexibility is one. We can take any shape, and we can basically dispense material in that shape. So the flexibility of the product itself, the fact that the product can accommodate the different stages from R&D all the way to production. This is something that we are very proud about. Each market will, of course, will require, and each market and each application and each device will require different capabilities. And again, because of the freedom and flexibility of this technology, multiple tasks can be achieved. The speed, as I mentioned before, the fact that you can develop and do production and deliver the product as fast as possible to the market is a very strong point. Cost. So the process doesn't require multiple steps. The process doesn't require extensive or any post-processing in most cases. It can all be achieved with one go. We do not require unique materials to be used for substrates. So for example, if we are taking LDS technology as an example, which is a very common technology for antenna printing, LDS will always require a unique substrate. So the material itself will always need to be enhanced with an additive, right? So the actual antenna injection molded part will need to be enhanced with an additive to comply with different laser or etching processes for the plating process itself. In our case, it is not required. A normal PC, PCABS, and more different types of plastics can be used without the need of any additives. Okay, here we can see some sensors applications. As I said, sensors is a very wide area that will, it's a very wide area that helps us to operate within the different industry segments. Okay, so we can see here a few nice examples. We can see even examples from the medical, so glucose sensor, you know, and we can see some other strain gauges, and later on we will see thermistors as well. So here's another example of a strain gauge. So here we can see it's actually a very nice illustration again of a step, right? So in a way, if you look at this part, there is a somewhat vertical printing involved as well. And this is another feature that can be done using our technology simply by tilting the print nozzle. Okay, we can actually do some vertical printing as well. Okay, so or sideways printing, let's call it, to a certain extent. Okay, but again, as I mentioned, very very flexible and very accommodating technology. Here we can see a torque sensor printed on a tool, and this is a thermistor printing. Okay, so as I mentioned previously, we are also quite strong in the display world. So display, again, there is always a need to, of course, to maximize the packaging size as well here, to, in some cases, to stretch those sides of the screen, right? So the only way to enable that is to really, so moving from these kind of edges of the screen to these kind of edges requires a different approach when we do the packaging. So in order to create that connectivity for the touchpad, right, you need a connectivity from the upper side of the panel to the rear side of the panel, so it will be connected to the rest of the electronics within the device. So we have found a way to easily print extremely fine. So as I mentioned before, in this kind of examples, we're showing you 15 micron lines, okay, to be printed on a glass and basically create a full, either a full wrap interconnect, okay, or a half wrap interconnect. The half wraps interconnects are mostly used in modular types of screens where you need to position panels one next to the other and create connectivity. Full wrap will be done for other touch devices, for example. Okay, but this can be easily achieved by our technologies by using the normal methods, our methods of dispensing, with combination of panel manipulation. Okay. Here we can see again some nice results with a very fine pitch, right? So we can see 15 micron line with space of 15 micron. Here is a nice profilometry scan, okay, just a height scan to show really the uniformity of the actual printed line. Okay, in terms of speed, we can achieve very nice throughput. For other unique applications, so here we can see something from the automotive world. So basically the de-icing, let's call it, of so conductive traces printed on the housing or light housing for the car. Okay, and that's especially relevant for the colder areas of the world, European, US markets. This is very interesting application, but again, you can imagine that this kind of capability can be taken to different types of applications, unique applications outside of the semiconductors, electronics, PCB and display world, right? So it's just to show that we can do many other interesting things. Here is a nice example from 3D structure, 3D structures, vertical structures as well. As you can see, these kind of applications are definitely doable. Here we can see another example. So as I mentioned before, we do have an option to integrate within our process a UV curing and a laser sintering device. So this gives us the option to actually print and cure as we go. Okay, and you can see these kind of structures can easily be created with those capabilities in mind. Here we can see a nice example of so here is a needle. This is a normal, very thin, tiny needle. And this just shows how fine our capabilities are and how fine we can go when we print different structures. Okay, so you can see these tiny poles are being printed from the tip of the needle. Okay, and a few more micron level with on-the-fly curing type of structures. Here are some other additional 3D-dimensional micron level structures. Okay, so a few words about the system itself that we are using. So our technology, again, when someone buys our system, they will always get it with with this unique UIM. So Decathlon system was basically created to enable our users to be able to utilize both atomizers and to be able to switch between the atomizers with regards to which ink you're using. So when you need an ultrasonic atomizer, you can see the process is relatively straightforward. It slides in. There is a small connection, a few connections to make, and you can start working. So very quick and straightforward process. And once you need to move to another ink, so possibly from metal ink to a dielectric ink or insulation ink, for insulation purposes, you can use the PA and just easily to slide it in. Okay, for the portfolio, so our standalone, or let's call it 2D type of operation portfolio. So the entry point to Aerosol Jet would always be the print engine. So for those customers who already have a certain who already have a system, a motion system or mechanics in place, and they just want to have the Aerosol Jet capability, the jetting capability integrated or implemented into that environment, that is definitely doable. We call this product the print engine. This includes the process software, the controls, the actual controllers, and the actual jetting system, okay, the delivery and jetting system. So this can be integrated into different motion systems or platforms. Okay, in some cases, machine builders like to engage with us. In other cases, the customers directly, but definitely doable and known operation for us. The first, or I would say the first entry, I would say entry level type of dispensing system will be the HAHD. This system also comes at different levels in terms of its capability and I would say the how fine we can go with it. Okay, but this system I've shown it to you before. It has a nice it's 2 and 2.5D capability with some load unload preparation as well for automation and inline processing. The AJ Flex, a slightly higher level system with an improved accuracy. So very, very accurate system. Don't get me wrong, this system is very accurate as well, but here we are really taking it to the next level and actually introducing some future upgrade path as well. So although it's a 2D system, you can integrate a fourth and fifth axis into this system by adding a trunnion. Okay, that can be done in a later stage, post-purchase, and we can easily start working on three-dimensional substrates as well. Okay, and our flagship standalone system is the 5X, which is a system that comes with all those, with the 5-axis operation included. This system operates with another software, which is Mastercam. And I'll say a few words about that in the next slides. But this is really the high-end system that is being used by different manufacturers. So while this is a standalone system, one head, as we said before, might not be good enough for production in some cases when it's a higher volume production. So we have done these kind of customizations before and created basically 5X quad system that, yes, will basically increase your throughput tremendously. In terms of integration of post-processing equipment within the system, as mentioned before, for metal inks, laser sintering can be integrated within the system. This is how it's mounted. Okay, so we have the actual jetting and we have the laser sintering component. Okay, so it is all done in one process. So you print the line and then you trace the line with the laser and sinter the metal ink. UV curing also similarly can be implemented into the system. As we can see, it's slightly different here. So we have the jetting head and then we have the UV components to cure the tracing, also done as an inline process. For software, so for 2 or 2.5D applications, we are using the VM tools process software. So this software will process the drawing and basically define the movement and the jetting process speed, etc., for the system. For 5-axis or for three-dimensional applications where we require 5-axis motion, we use Mastercam. So we have special relationships with Mastercam over the years on both of our product lines, metal and printed electronics. And we have a special plugin of Optomec within Mastercam that can enable our users to very easily switch between both and start designing the part, defining the process, and move straight to production. Okay, so, to conclude this presentation, Aerosol Jet is a very flexible, very diverse technology that can be used in multiple applications, multiple industries. We are able to operate in 2, 2.5, and 3D environment. we are able to dispense multiple inks, a huge number of inks for different purposes, and we are able to do it all in one process and one go. Okay, so thank you very much. That's the session for today. As I mentioned before, I think we might have some time now for some questions. So feel free, whether in English or Chinese. We have enough people here to help us to translate it. But we can also take the discussion offline. And if you're interested to hear more, we are more than happy to arrange for another call and to actually address your particular requirements and needs.
Okay, thank you. Thanks, Alice. That's quite a great, good presentation. So.